Our lesson today is to be able to find the range, the interquartile range, and any outliers in a set of data. The standards we're going to use today are 6SP2, 6SP3, and 6SP5C. The essential question, how can you describe the spread of a data set? Some of the vocabulary we're going to use today. First, a measure of variation is a measure that describes the distribution of a data set. A simple measure of variation to find is the range. The range of a data set is the difference between the greatest value and the least value. Alright? Here's an example of finding the range. The table at the right shows the lengths of several Burmese pythons captured for a study. Find and interpret the range of their lengths. So these are the lengths that are given, and the lengths are in feet. To find the least and greatest values, it's always good to organize the lengths from least to greatest. So if we take these values from the table and organize them in a linear fashion from least to greatest, we would have 5 as the least value, 18 and 5/10 as the greatest value. The range is the difference between the least and the greatest value, so the range of the length is 18 and 5/10 minus 5, or 13.5 feet. This means that the lengths vary by no more than 13.5 feet. So let's try to do the same thing for this question down below. The ages of people in line for a roller coaster are as follows: 15, 17, 21, 32, 41, 30, 25, 52, 16, 39, 11, and 24. Well, let's start with arranging those values from least to greatest. Looks like the least value here is 11. Alright, and I always like to cross out the values when I use them. So I'm looking for, let's see, the next least it looks like is 15. Then we have 16. Then we have 17. So we have 15. Then we have 16. Then we have 17. Anything else in the teens? It doesn't look like it. I see a 21. Right, looks like that would be the next value from least to greatest. And then anything else in the 20s? We have a 24 and a 25. 24, 25, right, from least to greatest. And then we have, let's see, anything else in the 20s? No, but we have a 30. Right. We have a, what else? 32. Cross that out. Let's see, anything else in the 30s? We have a 39. And then we have a 41. And we have the 52. The range is the difference between the greatest and least values. So the greatest value is 52, the least is 11. So if I want to find the range, I take the 52, subtract the 11, I get 1, and I get a 4. So 41 represents the range of the data. Once again, the range is the difference between the greatest and the least value. Alright? And it's always good to arrange the data from least to greatest in order for us to find the range rather easily. Okay. Now the next part of our lesson deals with finding the interquartile range. And some of the key ideas would be first, quartiles. Quartiles of data divide the data into 44 equal parts. Recall that the median, or the second quartile, divides the data set into 2 halves. So if we're given this data set here, first we divide the data in half. Because it's an even set of data, we'd have to add the 2 middle numbers together, divide by 2, so we get a median of 29. But that median of 29 splits the data into the lower half of the data and the upper half of the data. In order to find the interquartile range, we need the median of the lower half of data. That's called our first quartile, or the lower quartile, or Q1. And we also need the median of the upper half of data, which is called the upper quartile, or third quartile, or Q3. The interquartile range is the difference between the Q3 and the Q1. So if my Q3 is 32 and my Q1 is 22, the difference between them is 10, and 10 would represent the interquartile range. Alright, so let's try to do a problem on our own with some data. We're given the data in the form of this dot plot. We see different values, and the values represent the top speeds of 12 sports cars. We want to find and interpret that interquartile range. First, we have to start by arranging the data values from least to greatest. So it looks like the lowest value is 220. Then we have two scores of 230. All right, so I want to write them as well. Then we have two scores of 240. All right, so I want to write them as well. Then we have one score of 245. So we write that. I have three scores of 250. So I want to write all three scores. 250, 250, and 250. We have two scores of 260. So 260, 260, and then we have one score of 270. So first I've arranged my data from least to greatest. I want to double check, make sure that I've used all my data items. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me double check, make sure I have 12 items here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's always good to double check to make sure that you've used all of the items. First, we need the median. Because I have an even number of data items, 1, 2, 3, 4, 5, I'm going to have two middle scores. The two middle scores split that data right in half. So I'd have 6 scores in the lower half. I'd have 6 scores in the upper half. We need the median first. Well, the median is going to be the sum of 245 and 250 divided by 2. So that's going to give us 247.5. That's going to be our median. All right. Once I have the median, then I can find the median of the lower half of data. Because I have an even number of data items in the lower half, I'm going to have to add my two middle numbers in the lower half, divide them by 2, and that's going to give me 235 for my Q1 or lower quartile. I need to find the median of the upper half of data, right? There's 6 data items. I find the two middle numbers. I add them together and divide by 2. That's going to give me 255 for my upper quartile or Q3. Your interquartile range, we abbreviate that as IQR, right? Your IQR is the difference between your Q3 and your Q1. So to find the IQR, we would take 255, we would subtract 235, and we get an IQR of 20. All right? So the IQR is equal to 20. All right. Now, there's also down here a way that we can determine outliers, and that's what we're going to do on our next page. But just remember, if we're looking for the interquartile range, first I have to split my data in half. I find the median. Then I find the median of the lower half of the data. That's called my Q1 or lower quartile. I find the median of the upper half of data. That's called my Q3 or upper quartile. My interquartile range is the difference between my lower quartile and upper quartile, and that's where we get the 20 from. Okay. Now, there's a formula that we can use to check for outliers. In order to find an outlier, and we all know that an outlier, or we should know that an outlier is a data item that's much lower or much greater than all of the other data items. Up to this point, we've been finding outliers using what I like to call the eye test, right? Does the item look like it's much less than all of the other items? Does it look like it doesn't belong? Well, if it is, it's probably an outlier. Or if the number or the item is much greater than all of the other items, it's probably an outlier. But there's a mathematical formula that we can now use to determine if something is mathematically an outlier or not. And we're able to do this because we now know how to calculate the interquartile range. That interquartile range allows us to check for outliers. And here's the formula that we'll use. To find the lower outlier, we have to take the Q1 and subtract 1.5 times the interquartile range. That will be the lower boundary for a lower outlier, meaning anything less than that value would be an outlier. To find the upper boundary for an outlier, we take our Q3 and add 1.5 times my IQR. That's going to give us the value for the upper boundary for an outlier. let's see what that process looks like down here with this example. All right. So first thing we want to do is arrange our items from least to greatest. So I look to see what looks like the lowest item, and it looks like 350. All right, so I'm going to start with 350. That's my lowest item. Then we have 356, 356. Any other 350s? No. I have 364 and let's do 364. Any other 360s? No. Looks like 376 would be next. 376. What else do we have? 382. From least to greatest. What else? 390. 390. What's next? 396. And what else? 400. And 468. Double check, make sure we have all the items that we started with. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we should have 9 items here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So we have 9 items there. Now, if we're just using our eye test, it looks like 468 might be an outlier, but is it that much greater than all of the other items? I don't know. Maybe. That's the eye test that we've been using up to this point to determine an outlier. Right? It looks like it's much, it could be, it's definitely more than all the other items, but is it that much more? I don't know. But now we have a formula that we can use to determine if that's an outlier or not. And we just have to make sure we follow these steps. In step number 1, we want to arrange our items from least to greatest. Step number 2, we have to split our data in half. All right? And I start by finding the median. Because I have an odd number of data items, my median is going to be the middle number when arranged from least to greatest. So that median splits the data into the lower half of the data. I have these 4 items that are less than the median, and I have these 4 items that are greater than the median. I need to find now the median of the lower half of the items. So I have 2 middle numbers. I have to add them together, divide by 2, and that's going to give me 360 as my Q1 when I add these 2 numbers together and divide by 2. I need to find the middle of these 2 numbers. Right? I'd have to add these together and divide by 2. That's going to give me 398 as my Q3. To find the interquartile range, our IQR, we have to subtract the Q3 and the Q1. So I take my Q3 of 398, I subtract my Q1 of 360, and I get an IQR of 38. All right, that's my IQR. Now that interquartile range means that the middle 50% of the data has no more of a difference than 38. All right, so now we want to determine if that's an outlier or not. So the outlier calculation looks like this. To find the lower boundary, right? I like to label my outlier. We have to take our Q1 and we have to subtract 1.5 times the IQR. My Q1 is, what was that, 360. Then we have to subtract 1.5 times the IQR, which is 38. Now, with the calculators that we have in class, we have to use our order of operations first because the calculators won't do the order of operations for us. So I have to multiply the 1.5 times the 38. That's going to be 57. So 360 minus 57, that's going to give us 303 as our lower boundary for an outlier. And when we look at our data, I don't have any values that are less than 303. So there's no lower outlier. Well, let's try the upper boundary for an outlier. And that's going to be our Q3 plus 1.5 times your IQR, your interquartile range. Your Q3 is 398 plus your 1.5 times your IQR. That's going to be 1.5 times your 38. Using our calculators, we have to do the multiplication step first, so that's going to be 398 plus 57. And 398 plus 57 is going to be 455. Well, 455 is the upper boundary for our outliers. If we take a look at our data, 468 is greater than 455. So 468 is an outlier. And using our eye test, I'm not so sure if that's an outlier or not just by looking at it, but now that we have a mathematical formula that allows us to find the outlier, we are absolutely sure that 468 is an outlier. All right? So let's continue. All right? Let me just go back, make sure we did everything on that page we did. All right. So for you guys, all right, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 8 and 9. We've already done that. And so let's do this last problem, problem 7. Right? This will be it. The table shows the number of song downloads a group of friends made on Saturday. Here's the group of songs. Find and interpret the range of the data. To find the range, we want to arrange from least to greatest first. So that's going to be 6. That's going to be 8. That's going to be 9. Cross them out. 6, 8, 9. Then we have 10. Cross that out. Then we have 12. Then we have 14, 15, and 16. 14, 15, and 16. 14, 15, 16. Double check, make sure I have 8 items. I do. Because I have an even number of data items, right? Split my data in half. There's 4 and 4. To find the median, I need the middle of the two middle numbers. I add 10 and 12, that's 22. I divide that by 2, that's going to give me 11 for the median. Now it's not asking us for the median, right? So let me undo that because it is asking for the range first. So let's do that first. So it is asking us for the range. The range would be the difference between the greatest and least. So that's going to be 16, take away 6. That's going to give us 10 for the range. Alright? But if I want to find the interquartile range now, I have to take my data, right? And I'm going to recopy 6, 8, 9, 10, 12, 14, 15, and 16. I start by taking a look at my two middle numbers. Two middle numbers are 10 and 12. Add them together and divide by 2, and I get a median of 11. But that median splits the data, right, in half. So I have the lower half and upper half. To find my Q1, right, which is what we need to find the interquartile range, I need my Q1 and my Q3. I have to add 8 and 9 together, divide that by 2. I get 8.5 from my Q1. To find my Q3, I have to add my two middle numbers because I have 4 data items in the upper half. I have to find the median of my two middle numbers. I add 14 and 15, divide by 2, I get 14.5 as my Q3. To find the IQR, I need the difference of those two numbers. So I take my 14.5, I subtract my 8.5, and I get an IQR of 6. That is my interquartile range, which means that the middle 50% only varies by 6. The middle 50%, the middle one half of data varies by 6. Are there any outliers? Well, let's take a look at our outlier formula. To find the lower boundary for an outlier, we're going to have to take our Q1, and I'm going to subtract 1.5 times my IQR. My Q1 is 8.5, and I'm going to subtract 1.5 times, let's see, I'm going to subtract 1.5 times my IQR, which is 6. 8.5 minus 1.5 times 6 is 9. That actually gives me negative 0.5 from my lower boundary. We don't have any values that are less than 0, and negative 0.5 would be less than 0, so there's no lower outlier. Doesn't look like we have an upper outlier either, but let's at least find that boundary. And that boundary is going to be our Q3 plus 1.5 times the IQR. Our Q3 is 14.5 plus 1.5 times my IQR, interquartile range, which is 6. That's going to be 14.5 plus. I have to do my order of operations first, so that's going to be 9. Then I can add 14.5 plus 9, and that's going to be, let's see, 23.5. I don't have any value greater than 23.5, so there is no upper boundary, or there is no upper outlier as well. All right, just to recap everything. To find the range of data, we have to organize our data from least to greatest, or at least it's a good idea to do so, and then we just need the difference between the greatest and least. To find the interquartile range, we have a few steps. We range our data from least to greatest. Step 1. Step 2, we split that data in half. Find the median. Then find the median of the lower half of data, that's your Q1. Find the median of the upper half of data, that's your Q3. Your interquartile range is the difference between the Q3 and the Q1. All right? And then to test for outliers, we need that interquartile range. The formula that we use for the lower outlier is Q1 minus 1.5 times the IQR. And the formula that we use to find the upper boundary for an outlier is our Q3 plus 1.5 times your IQR. All right, I hope that this has been helpful, and see you guys soon.